Hey, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to explain the law of sines to you. So the law of sines will be used when you have to find a side or an angle in a triangle that is not a right triangle. So if you have two sides and an angle, or two angles and a side, you can find out the rest of the triangle and get whatever you're looking for. So let's start with it. First, we have just a random triangle with corners, angles labeled A, B, and C. Then the sides directly opposite from the angle is the lowercase of that letter. So here's uppercase A is an angle and lowercase a is a side. So it goes directly across. Then uppercase B, capital B is an angle, and then lowercase b is the side directly across from it. Then uppercase C is the angle, and directly across from that is lowercase c, which is the side. So what this law says is that the sine of A, the sine of angle A, over side A is equal or proportionate to like the sine of angle B over B, and that is also equal to sine of angle C over C. So the proportions of the sine of one angle over its corresponding angle directly across from it is equal to, the same proportion of like B, the sine of angle B over the side of B. So let's start with our two examples where we'll start with having two sides and an angle and then looking for another angle. And we'll then have two angles and a side and looking for another side. So we have this random triangle here. The bottom side is 10 and this slanted side is 9. The thing is, A, B, and C are not specific to like, oh, A's on the left side, B's on the bottom, C's the longest one. That's not a thing. It doesn't really matter. They're just placeholders there. So I'm going to say this angle is 100 if it's too small to see. So sine 100 over the angle directly opposite of it is 10. So sine 100 over 10 equals, the angle is sine x over 9 is the angle opposite that. So what are we going to do? Well, then we are going to move this 9 over and multiply. It'll be 9 times sine 100 degrees over 10 equals sine x. And then you're going to take like the sine -1 of both sides. You're going to do the sine inverse of both sides, which will cancel signs here. And then you'll have x equals sine -1 of 9 times sine 100 over 10. So then you'll just plug that into your calculator because I do not know sine 100 off the top of my head, but you can just plug in sine -1 of 9 times sine 100 divided by 10. Now, let's start where we start with two angles. So we already have our sines. So our big angle here is 160 degrees. So let's just start sine 160 degrees over the angle opposite it is our x term. Sine 160 degrees over x. So now our x is in the denominator instead of the numerator. Then the other angle we have is 8 degrees. So we're going to have to do, 8 degrees. But we don't have this angle over here. So what we can do is you could use this 8 degrees and find this other side and then use a law of sines. Another way to find it. Or you could just find this second angle in here, which we have 160 degrees and we have 8 degrees. Now, we have a 16 on the side, but we want to find the angle directly opposite of that. So what we're going to do is we're going to do 160 plus 8 is 168, and then a triangle has 180 degrees in it. So we're doing 180 minus 168, which will give us 12. So this new angle here that we needed is 12 degrees. So what we're going to do is we're going to use 12 degrees. So let's just say 12, that is sine 12. That is my fault. Sine 12 degrees over the side opposite it is 16. Now what are we going to do? Well, we could just cross multiply. So we'll have 16 sine 160 degrees equals x sine 12 degrees. And then we're going to divide by sine 12 on both sides. I like keeping it with just these signs until the very end, until you plug it into your calculator, because I don't want to have to round things. That's just not nice. So we'll have x equals 16 sine 160 degrees over sine 12 degrees. There would be your answer for whatever that side length is, and just plug that into your calculator and you will get that answer. I hope this video on the law of sines was helpful, and thank you for watching.